Use integration by parts to find the integral of x log x. Given that y is equal to log of x squared, find dy dx. The diagram shows part of the curve with the equation y equals root x log x. The shaded region R is bounded by the curve y equals root x log x, the line x equals e, and the x-axis from x equals 1 to x equals e. Find the volume of the solid generated when the region R is rotated 360 degrees about the x-axis, giving your answer in exact form. So that's the problem then. Let's have a little look at it. I've summarized it here. So there's three parts to it. So let's have a look at the first part then. This is integration by parts, so it's v du. This will have to be v, won't it? And this will have to be du because we cannot integrate log. So we've got answer equals then. So it's uv, u is x squared over 2, times v ln x, minus the integral of u, which is x squared over 2, times dv dx, which is log x differentiates to 1 over x dx. So this is equal to then, we've basically got x squared over 2 ln x, and then this x will cancel, it's x over 2 with a minus, so that integrates to minus x squared over 2, but there's already a 2 there, so that's over 4 plus k. Says A, given that b, so now b, y equals log of x all squared, so y is equal to something squared, so differentiate then, dy dx, something squared differentiates to 2 times the something to the 1 less than 2, which is 1, multiplied by the something differentiated. So we get dy dx then. Let's give ourselves a bit more room. Dy dx is equal to, it's 2 over x times ln x. So there's dy dx then. Now part C. We've got this curve here. We're going to rotate the region R 360 about OX. So the little delta V here of this cylinder is equal to the cylindrical area pi y squared. And it's of thickness delta x, isn't it? So there's our slice of volume. We need to sum those volumes between 1 and e. So let's have a go at that then. Part C. Here the volume is equal to the integral between 1 and e of pi y squared dx, isn't it? These cylinders summed between 1 and e, which is pi, the integral between 1 and e of y squared. If we square this, we get x times log x squared, x times ln x squared dx. Okay, so we know that the integral of in the previous problem, part B, okay, dy dx was 2 log n x, 2 over x. So this integrated, that's not going to be a lot of help, I don't think. So let's call this v, let's call this du, and see where we go. So this is equal to then pi times uv, x squared over 2, times v, which is ln x squared, minus the integral of u, which is x squared over 2, times dv dx, and that 2 times something to the 1, multiplied by the something differentiated, which is 1 over x dx. So we end up with then pi x squared over 2 ln x, that needs to be evaluated between 1 and e, of course, minus the 2's cancel, one of the x's will cancel, we'll get x ln x dx between 1 and e, and this of course is between 1 and e, isn't it? which we can put in here. So that's equal to that. Now, did we evaluate integral of x log x at all? No, we didn't. Oh, there we are in part 1, x log x in part 1 was this, so we can put that in. So there it is there. So this is equal to then. So I'm going to copy that here. So that's the integral of x log x. Edit, copy, paste, and I'm going to move that down now to here, because that'll be my integral value here. So that needs to be a minus in front of it. So it's equal to pi. This thing here, x squared over 2 ln x squared between e and 1 minus this whole thing here, and that would be between 1 and e. And we can get rid of the k. Okay, so that's what we've got then. Let's see if we can evaluate that then. Shouldn't be too bad. It's equal to pi. Put the e in, e squared over 2. Log of e is 1, 1 squared is 1, minus the log of 1 is 0. So that's that value. Minus bracket, top value, put the e in, we get e squared over 2. Log of e is 1, minus e squared over 4. That's the top value there. Minus the bottom value, put 1 in here, we get 0, and then put 1 in here, we get minus 1 quarter, don't we? So that's what we've got then. Okay, so let's just tidy it up then. So we've got equal to pi. E squared over 2 minus e squared over 2, they can cancel. And we get minus is e squared over 4. And then we get minus and minus is plus, but another minus is minus 1 quarter, which is equal to e squared minus 1, lots of pi, over 4.